So on here, remember that we're looking for a pair of variables that add to 0, or in other words, eliminate. The fancy term for that is additive inverses or opposites, but basically they cancel out. So on last night's, you had almost all of these that canceled out very easily. So you could just add them up, 2 plus 1 and get 3m. Bring down the equals. 14 minus 3 is 3. You'll notice how these were all in standard form. Both variables on the left, a number on the right. If they were not in standard form and you want to use the elimination method, you would have to move all the variables to left. So like some of those word problems, I think had an L equals something. That's not standard form, so you'd have to do a little work before using elimination. Okay? So all of these came out pretty easily. Also, don't be afraid if you got some fractions. It's okay to get an answer of 1.5. Usually when you go to buy something, you get some sort of change. That's the same as a fraction or a decimal. So don't just shun away from like it must be wrong because it's not even. 1.5 or negative 1.5 here is fine. Okay? So the question for today is, what happens here? You can't add these. 1 plus 3 doesn't eliminate. 2 plus 1 doesn't eliminate. So what happens if it does not eliminate easily? Okay. So pick a variable. In this case, we'll try x. If we want to eliminate x, and we see we have 3 here already, what number would we need here in order to eliminate? Negative 3. Now, much like yesterday, you can't just go ahead and put a number there because that's what you want. But there is a rule that says if you put it here, it's okay as long as you put it everywhere. So if you distribute it to everything, so we have negative 3x here, right? The bottom stays the same because we want them to eliminate. But as long as if you want a number to be there, as long as you do it everywhere, it's perfectly fine. So it'll be negative 6y, and even on to the other side, you got to do both sides. As long as you do it everywhere, now you have a situation much like yesterday's. Variable eliminates, and you can finish up the work. So this is the only thing new today is picking the number to set it up so that one variable, and of course sometimes both variables with infinite and no solutions, cancel out. Okay. But after this, entirely the same as elimination method, entirely the same as substitution method, the past 3 days. So let's go on to a few practice. This is an example we used yesterday that we can add any true equations and it stays true. It also stays true if we multiply one of those equations on both sides, we still get a true answer. So mathematically what we're doing is okay. You'll notice here, if I want to cancel out the a's, which equation, 1 or 2, do I need to multiply on, and what do I need to multiply by? If I want to cancel out a's, I got a positive 20 here. What number do I need here? Well, what number do you need here? You need negative 20. So what do you multiply by in order to get negative 20? You multiply by negative 2. You'll notice, of course, in order to get in order to get 0, you have to have one of them negative, one of them positive. But there's also another option. Well, what if I wanted to cancel out the b's? We got a positive 10 and a negative 30. What should I multiply by now? And which equation? Yeah. If I multiply the first equation by 3, Now I have positive 30, which will cancel out or eliminate with negative 30, and I can do it that way. So once again, very similar to substitution, you have multiple correct methods. So if your work does not match your neighbor's perfectly, but you have the same answer, you probably did two perfectly fine and correct problems, just in a different way. All right, so let's just do a little practice here. So just looking at here, what would we multiply by? Which equation, top to bottom, and what would we multiply by to cancel out a variable? Bottom by 4. So you look at these and say, well, x's don't really cancel out easily. I can't multiply by something by here and have it cancel out 2, and vice versa. So x is not so great. But here, yeah, 2 goes into 8, so I just need to multiply this by 4, and then I'll have a negative 8 and a positive 8. Remember, you can work with any variable. Sometimes both of them are equally the same. So let's focus on that. If I want to cancel out the y's, what should I multiply by? Bottom by
4.
Positive 4. If I want to multiply, cancel out the x's, what should I multiply by?
-3.
Yeah, negative 3. Positive 6, you need a negative 6. This is probably the most commonly missed part, is the negative. A lot of people, they just focus on having the same number. But you got to have different signs. One has to be positive, one has to be negative. Okay. And one more time here. Multiply by 2. Yeah, negative 4 and then positive 4. What about here? Yeah, it doesn't quite work. So think of this like a common denominator. What number does 2 and 3 both go into? What's the smallest number they both go into? 6, right? So we need one positive 6 and one negative 6. So let's multiply the top by 3, which means the bottom would be by a negative 2. So now I have a positive 6 and negative 6. So we have the option, if we have to, of multiplying both equations. Okay, both equations by some number. And treat it like a common denominator. What's the smallest number? Okay. So let's go to here, the second one here. What will we do here? So what's the common denominator, or the LCM? 15. So I need to multiply the top by 5 or negative 5, and the bottom by 3. One has to be positive, one has to be negative. Notice how these signs can be switched. I could have made the top positive, it'd be positive 5, and the bottom be negative 3. I still have a positive negative 15, 1 and 1 each. Okay. So slightly different step. It's kind of good, kind of bad, because you can personalize to whatever you want, but then when you're checking with your neighbor, like you're going to be in a moment, you have to be really careful, because we're so used to just saying, well, is yours the exact same as mine? Okay, something's wrong. But in this case, if they're not the exact same, they can both be right. It's perfectly fine. It just depends on what choices you made. So be careful on saying they're wrong because they don't match. All right, so from there, let's just go straight to your homework, which starts on number 7. Originally, I was going to have you guys graph the answers as well. We tried doing that earlier, but the numbers they gave us are like 19 and 16 over 7, and they don't actually fit on these graphs. So we're not going to do the graph as a check, okay? We're just going to do the same check we have been doing, plug your answer into the other equation to verify it's correct. But technically, whatever answer we get, if we graphed it, that's where they intersect. Don't forget what the meaning of all these answers are. If we graphed it, that's the point of intersection. So let's do number 7 here. Which variable would you like to cancel out, and what we need to multiply by? Any requests? So first choose a variable, x or y.
Y.
Okay, we're going to cancel out the y's. What's the LCM of 2 and 5? 10. So I need to get a positive 10 and a negative 10. Okay. So what do I have to multiply by on the top? 5. That'll give me a negative 10. And on the bottom, 2 or negative 2? 2. So I already have a negative 10 on top. I need a positive 10 on the bottom. Just like always on these, if there is a mistake, it will be with negatives. So just be careful. So here we go. 25x negative 10y equals 55. Bottom, 6x plus 10, okay, and 2 times 19, 38. And now it's set up just like something from yesterday. We have a variable that eliminates, and just finish it up. 31. 83. Is that right? Nope, 93. Plug them back into either one. Let's do the top. Lots of practice just plugging and solving. So we get our final answer, 3 and 2. Make sure you write it as a coordinate though. Go ahead and double check that. Plug it back into the bottom one. See if you get, on this case, see if you get 19 equals 19. If you don't, something's wrong. All right, so go ahead and do that. I'm going to plug 3 and 2. So 3 times 3 plus 5 times 2 equals 19. Does it work? Yeah, sure enough, we're okay. There you go. Remember, don't do all of this work. That takes a long time, and then skip the most important part. Hey, is this the right answer? It'll take us 4 seconds to figure out yes or no. There's no point doing all this and not even caring if it's right or wrong. It's like trying to fix a car, and then after you think you fixed it, you don't turn it on to see if it works or not. It's like, okay, I'm done. I tighten the last bolt, and that's it. You don't even care if it works. Like you have to. If you're doing this for a reason, let's make sure we did it right. Okay? And the check is very simple. Turn the car on. If it starts, it works. Plug it in. Just takes 4 seconds, and you know. Might as well check it out before you say you're done. Let's see here. Okay, and the rest is all the same. Like the next one, you'll notice that you only have to multiply the top by -2. So you'll have -4 on the bottom, +4 on top. So you'll have to be thinking, well, do I have to multiply just one or both of them? You'll have to be going back and forth. Again, don't do the graph at the end, just do the standard old check. You will get some no solutions and all reals, so don't forget about those. When you get to the word problem, please don't stop here and say, oh, I didn't know how to do those. That just means you didn't try. Because the first part, you don't really have to do anything. All this stuff right here, they already did all the work for you. They already translated. All that is just right here. So basically all they're saying is solve this, which is what you did already. Just make sure your answers actually add up to 180. So it's another way of checking your work. If you know that the two angles add up to 180, make sure your two answers add up to 180. Yep. Hold on. I'll leave it up to you for some of these. I would argue, like maybe on number 15, that this might be better for substitution here. If you look at 15, it's like, instead of trying to multiply everything by like, I mean, you could do this, multiply everything by -1.15, so it cancels out with +1.15. You could do that, but it might be even easier just to maybe subtract d on both sides, b equals 40 minus d, and just plug that back in right here. But it's up to you. Either method is going to be just as much as work, but experiment with both and see which one you prefer. And when I say which one you prefer, means which one gives you the right answer easier. Okay, so, oh, and of course at the end of a word problem, please write a summary of what your answer means. So we know that the two answers add up to 40. So if you get bagels equals 21 and d equals 19, just write a sentence saying, he bought 21 bagels and 19 donuts. Just write something at the end that summarizes, S is the, J is the, S is the shirts, J is the jeans. Write out in words, oh, we bought this many shirts and this many pairs of jeans. But these are not more work than the ones before without a word problem. It's the same thing with a one little sentence at the end. And I think that's it. We go up to number 19. 19 is just asking you basically, if I ask you, well, how do you start this problem? You know, number one, that you can cancel out the x's, and you have to do one set of steps, but if you want to cancel out the y's, you might do a different set of steps. So there's multiple correct answers. Okay, for the rest of the period, you guys will just be working. So get all the hardest problems, get all your questions answered, so you're able to go home, finish everything else on your own this weekend.